So this is the last half of the Chapter 8 test. So again, you should be writing these down on a separate sheet of paper for the ones you got wrong only, making your corrections, and then you'll staple that to your original test in order to be eligible to retake the test. So remember that when we factor, we're trying to break it into a multiplication problem. So in these first ones, our number one question we ask ourselves when we factor is, can I pull anything out or factor anything out first? Can I factor or divide or pull, whatever you want to think? Anything? I think I moved my screen a little bit here. I'll fix it. All right, so can I factor anything out first? On number 20, you can see that both 12 and 9 have a 3 in it. So really what I'm going to do is factor out or divide out a 3. When I divide it out of 12, I get 4, and the x is still in there. When I divide it out of 9, I get 3. And remember, we can always check that by multiplying back in, since they're inverse operations. So for number 21, is there anything in common or anything I can factor out of each term? And when you look at them, you should notice that each of them have a 4 in it. 4 goes into 4, 40, and 12. And they all also have an n in it. So what I'm going to do is factor out a 4n, or divide out a 4n. And then I have to decide what goes back in the parentheses. Well, when I remove a 4 and an n from 4n cubed, I end up with n squared. When I divide it out of 40n squared, I end up with 10n. And when I divide it out of 12n, I end up with just a 3. And again, this could be checked by multiplying it back in. And then we generally ask ourselves, are we done with it? Is there anything more I could do? And since this is a trinomial, I really should take the time to look and see if there's any way, oops, sorry, my eraser. Is there any way that I can get a 3 and still add up to negative 10? And you can't. So that one would be done. In this first row, all I'm doing is pulling out what we call a common monomial, or a term that's in everything. So what goes into 14 and 21? 7 should pop into your head. Does each term have b's in it? Yes, they do, but I can only take one out because that's the fewest that I have. Again, you can't remove more than that, or this term right here won't have enough to spare. Can I take c's out? And the answer would be yes. We can take 3 out of each. It's the lowest power that you see that you can remove. So again, we got to go back up and we have to divide this out. 14 divided by 7 is 2. When I remove a b, I get a b, and I don't need to have any more c's because I'm taking them all. When I divide out a 7 out of 21, I get a 3. When I divide a b out of b, they'd be gone. And when I divide 3 c's out of c to the 5th, I'd end up with 2 of them left in there. So my answer would be 7b c cubed times 2b plus 3c squared. Now on the next one, when I ask myself, can I take anything out, the answer is no. But that doesn't mean I can't factor it. It's just a different kind of factoring. This is the trinomial factoring, where we're basically trying to unfoil the trinomial. So remember, this comes from first, this comes from outside and inside combined, and this comes from last. So we talked in detail in class about how you're trying to multiply to equal 27, while at the same time adding up to 12. And 9 and 3 would be your winning pair. The only way you can get the r squared out of the firsts is r times r. I can get 27 out of 9 and 3, and when I run a check on my outside and inside, you'll notice they do add up to 12. Again, you can check all these by foiling them. So the answer to 23 would be r plus 3 times r plus 9. On to number 24. Again, the only way I can get the first terms is by multiplying g times g. So when I unfoil, I know my first terms are locked in there as a pair of g's. But there's multiple ways I can get the 24. So with 24 and 1, 12 and 2, 3 and 8, or 6 and 4. Remember, I need to select the pair that adds up to negative 2. We did a lot of sign analysis in here, and what I know is that if I multiply to equal negative 24, one of my two terms has to be negative. So is there any way to get a negative 2 out of those? No. 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 But this pair I certainly can as long as the 6 is negative. So I'd have minus 6 and plus 4. Again, I would FOIL it to check it. For the 35, the pair that pops into my head right away are 7 and 5. Is there any way I can get a 2 out of those? I can, as long as the 5 is negative. So again, you kind of got to look at the signs and say, all right, if I multiply to equal negative 35, I have to have one positive and one negative. And you're looking for that pair that when you combine them gives you the middle term. So I lead in my m's, and I'd end in a positive 7 and a negative 5. That would be the answer to number 25. So moving on to the next page, number 26, again I'm going to ask myself that question, is there anything I can pull out of every term before I start? And that's always the question I ask myself. And on number 26, the answer is still no. 3 goes into both of these, but it doesn't go into 13. So now I've got a little bit bigger problem here because I have to worry now. I can't just lead in d times d because I have this 3 here. I have to lead in 3d and 1d. And if you want to put the d's on there so that you don't forget them, you know that's how you have to lead it. You might even want to go put them down here. You have no choice but to lead in 3 and 1. That's the only way to get d squared. But there's multiple ways I could end this. I can end it in 6 and 2, I can end it in 4 and 3, or 12 and 1. Well, let's have a little sign analysis here before we pick our pair. I have a plus sign here, which means that they're either both positive or both negative. Well, the fact that the middle term is negative means that I'm going to have 2 negatives. So I'm going to go put those on here. So again, I'm going to try to pair them up, multiply them, and then add them, and try to get that middle term. So let's give it a shot. I'll tell you that just for time's sake, I'm going to just give you the winning pair right here. It'd be negative 9 and a negative 4. So you'll notice I linked my 3 here with the negative 3. So when I follow my 3 on the outside, a minus 3 goes in here, and the minus 4 goes in here. Again, if you FOIL that, you should get the correct answer. Number 27, again, number 1 question, can I pull anything out of every term? Well, they're all even, so I can for sure pull out a 2, and actually 4 goes into all the terms. So before I even start, I'm going to divide a 4 out of every single term, leaving me with this. What I would do now is go put a 4 on your answer blank so you don't forget about it. Now I'm concerned with this. Can it factor any farther? And if it does, I could only lead in a pair of y's. That's the only way to get y squared. My possible endings are 5 and 2, 10 and 1. Well, I need to add up to 7. So my other 2 factors would be y plus 5 times y plus 2. Moving on to the next one. These are the easiest kind if you recognize them. Those are the differences of squares where we said you have to lead in the same, end in the same, and have plus or minus to make the O and the I cancel. So those factor into x plus 3, x minus 3. Same right here. I have a difference of perfect squares, which means I have to lead in 2x times 2x, end in 5, 1 plus, 1 minus. And when I FOIL that, you'll notice 4x squared minus 10x plus 10x. It causes the elimination of the middle term that was in all the other ones. And then I get a minus 5 at the end. So for 29, I'd have 2x plus 5 times 2x minus 5. Number 30. Is there anything that I can pull out of every term? Well, they're all even, so for sure a 2. How about a 4? No. But they do all have an x in it. So the first thing I'm going to do is factor out a 2x. And I end up with this when I divide a 2x out of every term. Now again, I have to concern myself with this remaining one. Does it go any farther? Maybe, maybe not. We got to try it. If it does, it would have to lead in 2 and 1 and end in 3 and 1. Notice that this is a minus, so it means one or the other has to be negative. So let's go see if we can do that. And if we look at it, we can get a negative 6 out of 2 times negative 3 and a positive 1 out of 1 times 1. So I can break this up a little farther. I just have to be careful how I organize it. So I have the 2x I pulled out originally. I need to lead in a 2 and a 1x for my first terms. And then I want the 2, watch my link here, to go with a minus 3. So since this 2 is on the outside, I put a minus 3 on the outside, which means inside would go a positive 1. So that breaks into 3 factors. 2x times 2x plus 1 times x minus 3. Number 31, we've got the cereal box. And remember to get volume, we do length times width times height. And they're telling you to find the length, the width, and the height, the dimensions of the box. And it actually says it's the factors. So really what I need to do is factor it. So when I go up here, when I look at these, I notice that a 3 is on all of them and an x is. So I'm going to divide out a 3x. okay? So I divide an x out of every single term. That doesn't mean I'm done. Some people quit here. Really what you've done is broken it into two factors. Well, volume is length times width times height. I need to break it into three factors. So what I know is that this one must go farther. Well, how can I get that minus x in the middle? And I'm just going to show you the link just for time purposes, but normally I try 6 and 1, 3 and 2, but for this one, if I had a 3 and a 4, I could get that -1. However, the 4 would have to be negative. So run a little check here. Do these two multiply to equal -2? Yes. And when I pair them with my other two, watch what happens. Are the 3x I pulled out front? I know I need to lead for the remaining trinomial into 3x and 2x. I've also linked my 3 with a +1. So my 3 on the outside goes with a +1. And on the inside then goes a -2. Again, for checking these, I could FOIL this and then multiply everything by 3x and I'll get this original one back. I've got a rectangular serving tray that I know the area of. Area is base times height. And what I know is that equaled 3x squared plus 17x minus 56. Or you could even say length times width, either one. And they're giving you the width. So this is kind of nice because they do half of the problem for you. What they're saying is 3x squared plus 17x minus 56 can break into x plus 8 times something else. Again, you're looking, this is the width, we're in search of the length. Well, they're telling you what the first term factor is, so the only way I can multiply and get the 3x squared is if this is 3x. And the only way I can do my last to get 56 is if this is a 7. Again, you're unfoiling every time it asks you to factor. And then a sign analysis would tell me this has to be negative. So my missing length is 3x minus 7. And last but not least, the correction on number 33, the error analysis. What was done incorrectly in this problem where it got crossed out? Well, if I was doing this, I would FOIL. R squared times R squared is R to the 4th, so that looks good. R squared times negative 7x is negative, here, let me FOIL it underneath here. So I'd have R to the 4th with my first. My outside would be negative 7 R squared S. My inside would be positive 7 SR squared. And my lasts would be a positive times a negative makes a negative. 7 times 7 is 49, and S times S is S squared. And you'll notice that these terms are opposites, so they cancel. So the thing that was incorrect is that middle term. So some of you wrote O and I should have canceled, or some of you said there shouldn't be a 14 R squared S in the middle. All of that is good, and the correct answer should have been R to the 4th minus 49 S squared. So that's the end of the corrections. Again, you need to have had them written on a separate sheet, all work shown for the ones you got wrong. If you still don't understand what you did wrong, you need to ask me, and we will do the retake either Monday after school or Tuesday after school, one of those 2 days. And you just need to come in, you don't even need to schedule a time with me. If I don't see you by Tuesday after school, I'll just know that you're not opting to retake the test. Have a good day. Bye.